processor intensive.
Those of you just joining, sorry I forgot to record. Read this link. It tells you about salts very well. Man, whose job was it to tell me to hit the record button and y'all didn't? You fail, all of you.
Is that site called even Pro?
Yes, it is. Yeah, that's where you do this line. Oh, there you go. So you can go. Yeah, so if you can go to that IWS, you need to go. You get a T-shirt, free lunch. You know, it's not a bad deal. All right. So, Salt, please read over this document. It actually explains it very well. Now, what I want to do today is, last week or the week before, I did a somewhat demo of Wireshark. I've had so many people asking me more questions on that. I want to do a little more of that, a little more in depth, plus show you a couple added little features for it. Will that work? Can't hurt. If you're not in pen testing, well, pen testing already did the project, so it's too late now. But it can only help. It can help you later on, okay? So I'm going to capture some traffic here, and then we're going to look at it, okay? So we already know where to get Wireshark and all that cool stuff from, okay? And I need a link here. I added a link about a header, IP header, so we're going to use this here in a minute too. All right. What? Yes, I am recording. Let's make sure I'm recording. Yes, I'm recording now. Okay. So I'm going to start this recording here, and we're going to get some traffic, and I'm going to make some different kinds. I'm going to do ping BS-131, 31-01. Well, I'm not on the Wi-Fi network. Okay. So we're going to look at this one first. We're going to stop this traffic, and we're going to analyze this, and we're going to do a couple of different types of captures here today. Okay. Now, do I need to zoom in here? Can y'all? Well, we don't need that. Hit the zoom in a little bit. Okay. Now, y'all realize there's different types of packets out there.
Yes.
Okay, and there's different protocols. Like we have TCP/IP. Okay. What you have is, if you look at it like an hourglass, it's TCP or UDP, but they all go over IP. Okay. IP is the addressing information. It's kind of like the address on an envelope. We have had a temporary mail person in my house who can't read addresses. The other day I went to get my mail, and I had my neighbor's mail. Then my neighbor had their neighbor's mail, and they had the next neighbor's mail. It's like, seriously? They're screwing up so bad. So basically, having the correct address really doesn't help. IP is what's called a connectionless protocol. There's no connection made. It's just the addressing. TCP, on the other hand, that's the connection part. That's the mail person reading the address, well, hopefully reading the address, and putting it where it should go. Okay? I captured here an ICMP packet. This was one of the packets the students had to use in a project. Okay? Well, there's lots of different aspects of it. The frame is actually the part that went across the network cable. I'm going to start kind of in here in the middle at the IP version, because that's where a lot of questions came from. What? Well, I can move it over a little. There, right there. Okay. Now we're also going to need this handy dandy little tool.
Hey, Ken, question real quick. On the ping,
Yeah.
like on the answer, I have up the ping request.
Okay.
But you had it's a ping reply.
I'll answer that. Okay. The question was, in the assignment, I did not give full credit for some, because what it was actually an ICMP. That stands for Internet Control Messaging Protocol. That's used for checking connectivity. Are you there? That's what I did a second ago right here. What's happening is this machine is sending 32 bits of data to my machine in my office. Are you there? Yes, I'm there. Are you there? Yes, I'm there. And the -T tells it to go on forever. Okay? The TTL you see on the far right, that's time to live. Packets go out with a varying time to lives, but every time they go through a router, that gets decremented by 1. So obviously it didn't have to go far to get to my office, but if I was pinging Google or something, it could theoretically take longer. But I can't ping Google from here because we're blocked by our firewall. Okay? The time, how long did it take to get there? That's where you can test for network latency. If the time, if that number goes up, that means you got a slower connection. Okay, a lot of times you hear when people play games, they'll say, "Wow, I got a 1 ping time, no, or a 4 ping time, or the lower the number, the better." When I ran my ISP at my house years ago, my son would play his Xbox. He would actually take it out into the server room, plug it directly into my uplink router, and play with basically no latency at all, because it's direct connect straight to the internet, and you kill everybody. So it was
I need to do that.
You mispronounced Winnie.
yes, I don't have that anymore, but it was. Yeah. All right, so let's look at this packet again. To answer Leroy's question first, okay. Down here at the bottom, see what's happening is this packet is actually this hex data. That's what's going across the cable, okay. See, when I clicked on frame, that means this is the entire piece of data. All this fancy stuff we see up here in the middle, that's nothing more than Wireshark interpreting it for us. Okay, I had to write a program to do this interpreting. That's why I learned it probably better than ever. Okay, now on ICMP, when I click on that, you see this is the portion of the packet that pertains to ICMP. If I click on here, that's the portion that pertains to TCP. There's the Ethernet frame, so on and so forth. What now?
At the end of the packet.
Yes. All right, so under ICMP, under type right here, type actually comes from this bit right here. Okay, see that? That 00? Now that's in hex. So it's actually 8 zeros. Okay? But a 0 is a 0. Okay? So, now on some of the questions, the 0 is not a 0. We'll get there in a minute. Okay. Now, if you'll notice, that's a 0. Now, when I click on the request, you'll notice that same bit turned to an 8. See that? See the 8? So the request is an 8. The reply is a 0. That's how, when you told me it was an ICMP packet, that's true. It's kind of like saying it's a Chevy. Okay, but it's not a Chevy Volt. You know what I mean? You're not specifying it. What?
You didn't say which one.
I know. I wanted you to tell me as detailed as you can. Yeah, theoretically, you could have said it was a frame. I mean, no, I wanted... Yeah, I gave that... Yeah. ICMP, I think I gave half credit for it.
Yeah, I got that credit for it, but I'm just trying to...
Yeah.
I'm trying to...
Right, that's fine. Yeah, that's fine. I'm just trying to... See...
Guessing the correct answer would have been a ping reply in this case, then?
A ping reply would have been the correct answer in this case, yes. Okay. And, all right, so now I'm going to go back up and look at the IP protocol. Up here at the top, when I click on it, you'll see all the stuff that pertains to the IP protocol is now highlighted. Okay. Version gave a lot of people an issue. Okay. Version, when people click on it, they see 45. See the 45 down here?
Yes.
So here's what happens. People went in here to this programmer mode and they said, oh, this is hex. So hex 45 is 69. That's not true.
That's what you taught us in the previous,
It's not true. It's not for everything. Now I'm going to show you why. Okay. I added this link to the cyber page as well if you want to go to it. Now if you get in here, this actually starts telling you how the protocol suite works. And if you get down here into an IP header, you actually see it's telling us. It says the first 4 bits is the version number. Okay? Okay. The second 4 bits is the header length. Okay? So when I go back down here to this packet, I have 45. So the first 4 bits and then the second 4 bits. So let's bring 45 back up to hex. So if I need to go bits, what do I need to convert it to? Binary. So what are the first 4 bits from the left? Anybody? Not quite. The first 4 bits from the left is actually 0, 1, 0, 0. Because remember, it's 8 bits. It cut off the other one. That was actually an issue for a lot of people.
Sometimes it cuts off that extra bit.
Right. So really, the first 4 bits is 0, 1, 0, 0, which is 4. So our version is 4. So that part's easy. Now the problem is the other 4 bits, the 0, 1, 0, 1, which is actually 5. If in binary, if I type in 0, 1, 0, 1, it's a 5. So yeah, is displaying correctly, and 5 in decimal is 5 in hex. So it's not an issue. Well, so wait a minute. If it's a 5 in decimal and in hex, that one, hex and decimal, whoo.
At least you don't say trio vigesimal.
So how did I get a 20? So let's say I wanted a 20.
Power 23.
Obviously it's not that number, so it can't be that number, it's too big. Well, if you read this document, it's an awesome document. It actually tells you that it's actually the number of 32-bit words. Okay? Headers is identified that way. So 32-bit words, 8-bit is a byte. So you end up with that 5 times 4. 8 times 4 is 32, so you're dividing 32 by 8 and you get 4. 5 times 4 is 20. That's our header length. Okay? So what they're saying is packets are in groups of 32. Okay? So, I mean, you know, I could literally sit here for weeks going over every single bit of this. But, I mean, this chart tells you all. You just have to know how to read it.
There was a good webpage I found that helped me find, on the second packet,
Right.
Based off the flags,
Right.
how to find those where you take.
And I'm going to show you the flags right now, actually.
So is that last number always going to be actually multiplied by 4? Or is
Yeah,
that-
because it's 32-bit. Now, let me go back to that page. It does say here that it can include options. Okay? Packets can include options, which is different capabilities, basically, which most of them don't anymore. Okay? So, this is, just something good to read. Okay? So why is version only using up 4 bits? Anybody know?
That's all it really needs. I mean,
Right. What they looked at it, they're like, okay, what's theoretically the largest number we could put in there? So with 4 bits, so if I went into binary and I did 4 bits, that's the maximum they can be. Convert that to decimal, that's basically 15. So what they assumed was, well, first of all, this is an IP4 packet, so it's never going to go above 4. They just assumed 15 would be a large enough number, and it's never used. IPv6 actually changed all that. Okay? But again, this is an IPv4 packet. Okay.
15 times 5 is 75.
Yeah, so it could be
we never
bigger.
go over 60,
All right, so let's go back into here. So, there's just, some of that information. This DSCP here, let me expand this. Now, what's nice about here is you can expand this out. For the assignment, I specifically said, what is the DSCP, Differential Services Code Point, in binary, showing the correct number of bits.
That's where I got wrong. I had 4 instead of 6.
Right, it's actually 6 bits. The last 2 bits of that 8-bit grouping is actually the ECN. Now, really it was 00, but I was nice. I accepted a single 0 on that one because I didn't want to take off both. Okay. So, all right. So all this comes from right here. Okay. Flags. Flags got a lot of people. Okay. Now this flag's short. TCP, we'll get that one in for a second.
It's fun.
But flags, so the reserved bit, especially bit, is just this single 0. So when I asked what the flags were, I didn't ask for IP, but I did for TCP. It would have just been a 0. If I had, like the don't fragment flag, if that was set to a 1, that would tell your router, do not fragment this packet. Okay?
You can actually do that in your ping if you want.
Yes, you can. You can make it bigger where it changes all kinds of stuff. Time to live is 7F. So if it's 7F down here, remember that time to live is how many hops through the routers it can go through. So it's 7F. How did we get 127? Well, go into hex, put in 7F, convert to decimals, 127. So it's really straightforward. You just had to know where to look. And what gets a lot of people is expanding these little pluses. Okay. I want to get a TCP packet now. Do I happen to have one? Surely I do. There we go. Okay, here's the TCP packet. Okay, so you'll notice now we have a TCP, but TCP is on top of IP. Remember I said it was either TCP or UDP, and they both work on top of IP. Okay, The difference between TCP and UDP is the connection or connectionless. TCP is connection oriented. UDP is connectionless. UDP is not used as much anymore. In the past, UDP was used for video streaming. Okay? Think about it. You're watching a video stream and you lose a packet. Is it going to bother you? No. So why care? Where TCP would have to make sure every packet made through. That's why video streaming a while ago used to be UDP. Printing, like network printing, was always done through UDP because you print it internally. Internally, we have higher speed networks. Okay, but let's look at this TCP one. This one has a lot of information in it. We have ports. Okay, now source and destination. When you surf the internet, what port do you go on? 80. So does that mean when I surfed on this computer, I used port 80? I went to the other machine's port 80. But my source port was in other port. My port was 62,124. Okay. And then the port on the server was port 80. Everybody see that? Okay. And you can get these by clicking here and then 0050. We did here, so 50 converts, we're going to get port 80. Straightforward on those, okay? Some of the ports that are larger, you'll see they take up both hex groupings. Ports that are smaller only take up one.
I guess that's where I got confused, because when I went down to the hex, I was thinking that I need to convert that hex to decimal, not thinking that that's the decimal that you're wanting.
Well, the 80 is the decimal I'm wanting, but it really came across as 50. What I showed you was 50, but what I wanted was 80. Okay? All right. Sequence numbers. Now, let's talk about sequence numbers for a second. Sequence numbers are a randomly generated 32-bit number, so a very large number. So 32-bit, think of 32 ones and zeros. What's the maximum number you can put in there? It's quite large. So sequence numbers increase with every packet. So we started a number. We randomly pick a number, say, I'm going to start at 2 million, blah, blah, blah. Then every time I send Leroy something, I'm going to increase that by 1. So that way on the other end, he can reassemble it. Actually, it gets assembled along the way as well. But when it gets to his machine, he can put it back into order. Okay? Wireshark will show you a relative sequence number. I showed you that last time. It's under Edit Protocols TCP, which I don't like it doing that because it really confuses people. But in here, it stores it right down there. Okay? So if I was to take A0, did I hit A? A0, 73.
You're a decimal.
Oh, duh. A073B681. So that's what it is down there. If I convert that to decimal, I end up with 2691937, which is that number right there. Okay? Easy enough. Wasn't it?
I had that number, but well, I had a big number like that.
Okay, so let's.
It's like it starts out calm and then it's just it's just gone.
All right, now here's what killed, I'd say, a lot of people: flags. Flags. A lot of people gave me this. Bless you. They're like 000000010000. That's wrong. It's not the right answer. The right answer was these. So urgent is 0. ECN 0. Congestion 0. Not 0. Acknowledgement was a 1 because this happened to be an acknowledged packet. Okay. Push is 0. Reset is 0. Sing is 0. What happens is we take this entire string and each bit is used like I think she said the other, like a switch. It's either on or off. So it knows. And I actually did a project when I was at the University of Tulsa. You know, like the don't fragment flag. You know, we looked at that one a minute ago. You think that's very important, that one specific flag? It's not. It really isn't. But you could very easily encode data into that. What if I made something that all it did was it manipulated the don't fragment flag, and I was sending data to Leroy? So whether that flag was on was a 1, whether it was off was a 0, and I was encoded something in that. which would actually be very easy to do, and people have done that. Okay. Same with all these. Okay. Now the ACK, the SYN, the FIN, all those. No, you can't encode anything in those because those change with every packet. That would really screw things up. But flags was just these individual bits. It wasn't this whole big old number. Okay. Because really, I mean, if you tell me this big old number, it's like I'm going to go hit that light switch, but there's 8 switches. I mean, really, I want on or off. I don't want 8 on or offs. Okay? So flag, kind of important thing there. Yeah. Okay. The majority of the rest of these, 256, it's all, just conversions. Nothing special there. I want to go up to the addresses. So I'm going to go up into IP. Let's go. Where's the darn? Oh, there. Okay. There's the hex address. Now, MAC address we talked about, media access control layer. It's the physical address of the machine, and you can see these here. I mean, these aren't converted at all. Why? Because MAC addresses are given that way. They're given in hex. Somebody submitted an assignment. Actually, I think it was this assignment. No, it wasn't. It was one before that. And they got a 0. But they had a lot of right answers. So what they had done was, when I put stuff in D2L, I'm kind of hoping you answer the question. Don't tell me hex, and then give me the hex value. Just put in the hex value.
Right.
So, and after something in decimal, don't say decimal and then the number. But what he did is he gave me hex and decimal for everything. It's like, no, I don't want that. I want just the one I'm asking for. So those are straightforward there. How does this thing know it's a Cisco? Does anybody know? MAC addresses are unique, and the first, is it 4? The first 4 hex values are set to different manufacturers. So you can actually look at that and know, hey, this is a Cisco device. Okay. And Wireshark is smart enough to know that. Now the type right here is IP. That would change based on, if we were doing something else. Okay. If we had a different protocol type. Let's see. What do I want to show you in here now? There it is. Source and destination. So source is 1060.200.96. How did I get that? So if I did hex, actually let's do it this way. We'll do 10 for decimal, convert to hex, I get an A. So is that what you show at the bottom there? Actually it is.
That's how I got that one wrong.
It is.
Now I see what I did wrong.
It says 0A.
That's how I got it got legitimate, you could get a legitimate IP address, but I just wanted one big block.
It would have been 10.60.200.96.
Well.
Okay, so 3C. Let's see what 3C is. 3C is 60. 10.60. Okay, so 200 is C8. C8 is 200. Easy enough. So majority of this is all straightforward stuff. Okay. See, a lot of people think, data comes through his binary, actually comes through his hex, just like this. Okay. So there's our addressing, the same way for destination address. But, don't you guys think this is cool? You can actually see how it's getting it. All Wireshark is doing is showing it to us. Okay. All right, let's see if we can find a different type of packet. Here's an ARP packet. I didn't give you one of these. I think you had one of these for assignment 4. Okay. This one's different. Well, first of all, up here at the top, I got a lot of F's. That's not Leroy's grade. No. No. All right, so why would the destination be F's with an ARP packet? It's a broadcast. ARP stands for Address Resolution Protocol. I know I've said this before, but I'll cover it again. So say I want to cruise to Google. Okay. First thing I do is I look and see if Google's on my local network. Well, it's not. Okay. I look at Google's address, I look at my address, and I'm like, it's not the same network. So then what I do is I send a request out to find the router. If I don't know about the router, I send out an ARP request looking for the router. But normally, and the ARP request goes out as a broadcast. But down here, when I did this whole pinging of this address, the very first one I did, I sent out a broadcast say, where are you? Okay, where is 10.50.200.34, and to send it out to everybody, and there should be a reply. Let's see if we can't find it. Who has, actually this is for a different number, but it says, who has 10.60.19.10? Tell 10.60.200.89. So what it was is 10.60.289 is trying to talk to 10.60.19.10. So it sends a broadcast out, hey, does anybody know this guy? If you know this guy, tell me about it. So that's what that packet is. And the destination means it goes to everybody, and the source is that 10.60.200.89. Okay? And since we're talking internal to our network, we do everything in MAC addresses. That's why you see the source and destination are all MAC based instead of IP addresses. So why wouldn't we use IPs instead? Internally.
Because it's quicker.
It's quicker.
Can't they change?
They can change. I can change my IP address all day long. Old client of mine, Chapel Supply, they sell this pressure washer stuff. This guy, he would remotely get in from home to work and from work to home. But man, we had the hardest time. His IP at home kept changing. And back then there wasn't a lot of easy ways like dynamic DNS and all that. But his IP kept changing. So I went out there and he had SBC Yahoo DSL at the time. They actually were changing his IP like every minute. I was watching, it's like, dude, it just changed again. A minute later, it changed again. I'm like, I've never seen that. What normally happens is, actually, let me show you on this one. Okay, I'm going to do IP config. IP config tells you my IP address. My IP address is 10.60.200.96. It tells you my subnet mask and even tells me the gateway. Now if I go, actually if I do it with all, it tells me a lot more. Okay, and one of them down here is my DHCP server, this 10.1.3.74. That's the machine that's giving me the address. And you can see I got my lease on September 29th, and my lease is good until when? October 7th. What's that, a 10-day lease?
Wow.
Which is kind of long. Okay? But, you know, so like in my house, is a 10-day one too long? Well, it really depends. If you're having a lot of mobile traffic, people coming and going, you want shorter leases.
1 minute leases.
Well, an hour or so. I will tell you, you can set unlimited leases so they never expire. Don't ever do that. Bad idea. I did it for that same company, Chapel Supply, and their internal network, because I was never renumbering the machines. Well, I needed to change one day. I needed to change the IP. I couldn't get it to release. Because the machine, what happens is the server tells the machine, this is your address for life. The machine never goes back and asks the server again. So I'd even go on the server and delete it. It didn't matter. The machine would never contact the server again. Because it's like, oh no, I'm good. Got this for life. Don't bother come talk to me. It's like, don't ever do that again. Bad idea. Yeah, it was crazy.
So just do 9,999
Yeah.
days, right?
But no, it was nuts. Okay. But IP, and you know, down here they talk about things like Win servers. You guys might learn about that in your internal networks class, but Win servers aren't really used anymore. Stands for Windows Internet Name Servers. It was really used to resolve names to addresses, kind of like DNS does nowadays, but it was for internal networks. But it also would store things like what services you offered. Maybe you were a print server or a file server or whatever. But now it's not used much anymore. DNS does everything. But back then it was kind of important, and it's still kind of left over. I don't know why it's still left over. And Microsoft answered to everything. If you ever had a resolution issue, oh, delete the database and let it rebuild itself. Yet they'd always tell you to make sure you backed it up. It was crazy. It was stupid. Okay.
Back up your database and delete it.
Yeah, they're always like, make sure you back up your database and delete it. Why? We never ever restore it. Okay. All right, let's continue on. Okay, so ARP, address resolution. Oh, I want to show you one more thing while we're in here. And I can actually type ARP-A. And what it does is it gives me a listing of my entire ARP table. That's ARP-A. ARP entries are either in here for 2 minutes or 10 minutes. If they're used frequently, they stay for 10 minutes. If they're used infrequently, they only stay for 2 minutes. I don't know how it makes that determination of frequently or non-frequently. But what this is every IP address that this machine has communicated with, it stores it. And that changes. Okay. You can do what's called static ARP, where you could go in and manually add these, but that's a bad idea. What happens if Row State decided to change the IP scheme or something? It would really screw it up.
Those are dynamic. That means they can change.
Right, they can change. But you can make it static so they wouldn't change. But it's just tough. Now there are some static ones. These are normally multicasts and stuff like that.
So Ken, what would happen if I were to go out and say that
Use Kane?
my address was
Yeah, there's something called ARP poisoning. Okay. There's a tool out there called Kane, which we'll use someday. But we use it in the other class. But Kane is kind of cool. You can actually go in and tell each other, like, our gateway right here is 10.60.1.1. That's the gateway. So when I want to talk to Google, I go out through the gateway. Okay? And I can find that out by route print. I can find it out based on my routing table. Hopefully you guys are learning all this stuff. I'm going over it very quickly. But basically, my default route is listed at the top here. This basically tells the computer, hey, if you want to go anywhere and you don't know where it is, send it over to that guy. That's the default route, okay? And the metrics is how far away it is, so it's, but really the lower the number, the better there. But with Kane, you can go in and manipulate that. So I could tell in Rose's entire network, oh, by the way, Leroy, I am now the gateway. And what would happen is all of Leroy's traffic out the internet would go through me. It's very scary. You can do it very easily at like IHOP or something. It's literally one click of a mouse. It's very easy.
Excuse me, everyone, I'm the gateway.
And that's all it is.
Send me all your money.
The problem is you can really screw things up with that. Now, Kane's nice enough that when you turn it off, so basically I'm capturing all Leroy's traffic right now. It's going through me. Well, when I turn it off, Kane's nice enough to tell Leroy, hey, Leroy, the gateway is really over there. But what if you turn it off incorrectly? Then Leroy's like, dude, where'd the gateway go? So you never know when you're... So if you're ever at an airport or somewhere, you could really screw things up. So.
Or if
Okay.
you just point it towards a host that isn't there anymore.
All right,
He's
so
the gateway.
let's continue on. So we looked at it in our packet. The padding is just so it has some size to it. Let's see what else we can look at here. All right, I want to make a new capture. I'm going to show you a really, really, really cool tool. Okay. Continue without saving. Yes.
Oh, no.
All right, I'm going to surf some internet here.
I'm excited.
You like kitties? Look at all the kitties. We got kitties everywhere.
I'm very excited right now.
Everybody like, oh, look at the blue kitty. Oh, there we are, kitties in socks.
Hey, Ken, I have a question.
What?
Next assignment going to be over cats?
No. Now we're going to do puppies. This looks like my son's puppy.
That's a husky, and I'm okay with it.
Yeah.
Bad husky for the win. Other husky
right.
for the win.
I
All
just
these
saw a
huskies.
gerbil.
All right.
I have a question.
Let me stop my
Look for the
captain.
husky
Yes.
wolf mix.
Like on the next digital forensics assignment, you give us stuff to look through, and you ask us, like one of the questions would contain a grouping of such, but it's not a website, or it's not this, how do we know? Without giving away the answer, how do we know? Like,
Okay, what was the question again?
it's like which package contained a grouping of bomb-making materials, not a web page, or not about, or
That one.
Oh, yeah.
I thought
Search for bomb making stuff, but something is not.
Well, I did, and I wrote down like 5 different packages that had stuff to do with it. So how would I
Are they not websites?
I mean, all of them, I guess, are websites.
There's one that's not a website.
But it literally says that like in the info.
It's just a list of items. It's literally just a list of items. If you go to that packet, the data will actually just show the stuff. And this next thing I'm going to show you might help you.
Right, I was fixing to say, if you're showing them what I think
Okay, you
you're
ready
showing
to
them,
see
it'll
this?
basically
Okay, y'all got to learn now. We just captured some data. Everybody okay with that? I'm going to save it. I'm going to save this as a plain old, plain old top one. We're going to call this.
No, that's PCAP and G. PCAP.
P-
Second one.
There it is. We're going to save it as a plain old PCAP. This is kitties, puppies. All right, so we saved it.
This is the world's best data. We need this to save the world.
Okay, do I close it out?
This is where we invented.
All right, so what it is, so even if I close this out, you can actually save captures, okay? So you can save captures and open them up again very easily. Y'all see that? So I saved it and opened it up. Well, there's a tool called NetworkMiner, which is free. You can open it.
Open, is it?
Oh, it'll open.
Well, that's what you use to pull things out of.
And then you can just dump this packet in here.
Capture the packet.
I mean, dump the packet capture.
That's so quick.
Now I can go in here and I can look at all the kitties
Look how cute they are.
and the puppies. So I really just took the tool NetworkMiner, dumped my packet capture in there, and look, I mean, it tells me all the files that were there.
No, Ken, go
How
to
many
the
of those are
website and type in
certs?
a password.
And
It
well,
won't actually do anything.
no, it won't because it'll
Won't
be.
capture anything.
Here's the different hosts I connected to,
You can text though.
MAC address, which type of machine it was. All that information is stored on here.
Ken, see if it'll do credentials for like an FTP server. Like an unsecure one.
Okay, we'll try that in a second.
Okay.
That's what
Trying
I
to
was.
give away
That's,
the answers for this next assignment.
I always demo an FTP server anyway.
Right, it's
Okay, but you can see the certificates. A lot of these should be certificates. Yep, these are Class A certificates.
Yep.
I think I can actually,
lots of certs. You should be able to extract.
should be able to view them. Open file. There it is. I can actually see the certificate that came in.
Ooh, certificates.
Yeah.
Good old GeoTrust.
All right. So I can obviously see the images. If there was some message, I can see the different sessions that happened. Now, I've never showed this in a forensics class, so those of you doing this project are getting a very big bonus.
okay.
Yes.
Bonus.
All right, and you can see all the different parameters. Now I'm going to capture again, but this time I'm going to get into an FTP
You gotta
site.
pay attention to know what he's talking about with his bonus.
Yes, Mr. Programmer.
And just pop up when it says bonus.
Oh, well, bonus.
Sorry.
I heard the word bonus.
Okay, I'm going to FTP. Okay, we're going to. Shit. A-N-O-N-N-Y.
I'm sitting here learning things I'm going to need to use over the weekend.
There we go. Let's go into pub. Let's go into labs. Now let's go back one. That's good enough. We
As
just.
they're tracking you, get out.
Oh, I'm out. Done. Stop. Shh. That was close. They were right at the door. Okay. So I'm going to save this. And I'm going to save it as a PCAP file. Your assignment happens to be a PCAP file.
It has to be a PCAP.
But their assignment is a PCAP. Alright, so I'm going to open up NetworkMiner. And you can just search for NetworkMiner all one word. It's right on SourceForge and you can just download it. Okay, and then where'd my FTP? Let's see what that one got me.
Come on. Oh, credentials. It did it.
Anonymous, and look at that password right there. Isn't that special?
And this is why FTP is inherently insecure.
That's right.
SFTP.
Alright,
Told you.
so you can see my sessions. And there's really, I didn't really.
Well, for anyone who's in
What?
the club, something like this is similar to.
Well, it
what
showed
you
the
have to be able
actual.
to do for kids.
I didn't transfer any.
That's a wow
If I had transferred a
Holy
file, it
crap,
would have
I
showed
typed
it.
in a thing,
But I didn't
you
transfer
got
any
it.
files.
The file, no, I mean like
Well,
the
you
actual
just put a-
packet, like the breakout like
Keylogger
Wireshark.
in there.
Oh, you mean like you can file TCP stream or
Right,
something?
this is all over the network,
Kinda.
man. This can get you from
What do you-
anywhere.
They would do it there.
What do you see in here? Are you talking like?
I need to start.
You mean
I
view
have
this?
Wireshark in my house.
Hey, hush!
So what? So breakdown.
What do you mean a breakdown?
Like a breakout, like how it's breaking it out right there with Wireshark. Was it the same thing on?
Oh, will it show all this stuff? No, it won't. No, it
It
won't.
doesn't actually show the individual packet.
It'll actually show. Well, it shows the frame. Well, no, it doesn't show all of it though.
It shows a high-level interpretation.
Right, it
whereas
doesn't-
Wireshark is like base. Low
I think this is kind of like, this tool's for a specific use, but they're not going to show you everything. What?
What's the clear text?
Clear.
That's very right, clear text.
Those are all those things that I was seeing on the screen. Remember when I was typing all those things that were coming back and forth? Does it have like LS? Yep, there it is. The port command, FTP, download, so on and so forth. So kind of a really cool tool. I'm not about to log into something secure, but it shouldn't have been able to get it anyway.
If you logged into Google, it hits HTTPS before you. Even
Yeah,
log
so it
into
won't get
so
it.
wouldn't get you
Okay.
anything.
There you go. I'm going to mask my passwords. So now you can't see it.
That's your SSH.
All right. So those of you working on this project, this might help you, I hope. I do need to, maybe I'll send a note. Y'all need to watch this recording at like however many minutes in. All right. Don't tell them.
Hey, kind of like you said you would send us a hint last week and you never did.
Yeah, I was telling her I forgot the data change and there was no hint for that one. Sorry, man.
The lack of a hint was your hint.
Yeah, sorry. No, because I forgot the hint was actually for last year's.
I still missed 3 and apparently I mistyped one in, so I still.
All right, so that's about it. Hopefully I explained a little bit better how to use some of these things. Leroy, you a little bit clearer? Okay, good. All right. Now Leroy calls me, is it daily or hourly?
Hourly.
Yeah.
And daily. Both.
Okay. Yes.
I have no problem you guys asking me questions, come to see me. Just sometimes I'm not there, I'm busy, but that's fine. So, all right, let me stop this recording.
Is NetworkMiner,
Yeah.
is that freeware?
Yes, it is. It comes off of SourceForge. Anything off of SourceForge, here, let me show you where to get it from real quick. If you type in NetworkMiner, it's right there, SourceForge. Yeah, SourceForge is a good source for lots of tools. It's like a trusted place. So if you're ever getting something and it says it comes from SourceForge, I'd be okay with it. Okay?
That'll pull off documents, anything.
Yeah, pull off documents, everything.
That's what I thought.
Graphics, everything. Whatever is in the data. Yeah, because if I was to, like, obviously you got the pictures, so.
Right.
Just rebuilds it.
Yeah, just rebuilds it, exactly.
Do you remember that cane thing that we were
All right.
talking about?